Example 2. Write the next three terms of each geometric sequence, then graph the sequence. So this is where we're going to start really focusing on the geometric part of things, and especially because if we're going to graph it, this is where I'm going to start putting our sequence back in a table. So we're going to get our table back. Keep in mind when you're doing these, this is the first number, second number, third, fourth, and then they want the next three. So we're going to have to do 5, 6, and 7, which means we're going to have to go find our pattern. So from 1 to 3, and they specifically told you it's geometric. So if it's geometric, I know I'm multiplying. So I multiply by 3. 3 to 9, multiply by 3. 9 to 27, multiply by 3. So grab your calculator. 27 times 3 is 81. Times by 3 again is 243. Times by 3 again is 729. So the first part where it says write the next three terms of the pattern, you would write 81, 243, and 729. Then they're going to tell us to graph this. So if I'm graphing this, it looks like everything is positive to me. So I'm probably going to stick with the first quadrant. And it looks like I'm just going to go to 5. I'm not going to graph the whole thing because this is huge. So honestly, we might even count by like tens. So 10, 20, 30, 40, 50, 60, 70, 80. And then over on our x-axis, 1, 2, 3, 4, 5. If we're going to graph this, 1, 1, it's going to be relatively small. 2, 3, still relatively small. 3, 9, we almost made it to 10. 4, 27, that's almost at 30. And then 5, 81 is going to be really large. So what do you notice this time? They don't look linear. Do you notice this is exponential? And in fact, this is exponential growth. If I kept going the other way, it would get smaller and smaller, but never hit 0. That would be our horizontal asymptote. And then it would come up and get really, really fast. Letter C. So letter C, I'm going to put our table back because we're going to have to graph this thing eventually. So this is 1, 2, 3, 4, and then we have to find 5, 6, and 7. Find your pattern. 2500 to 500. Let's see. Well, that's big. 500 to 100, it looks like we're getting rid of like a fifth. I think this is a fifth. And then 100 to 20, I think this is a fifth. Okay, grab your calculator and check that. So if we take 100 times 1/5, we do get 20. 500 times 1/5, 2500 times 1/5. So essentially what you're doing here is you're dividing by 5. So 20 times 1/5 is 4. Times 1/5 is 4/5. Times 1/5 again is 4/25. Whew. It's getting really small. Okay, so the first part where you had to find the next three terms in the pattern is right here. But then we have to graph. Now, once again, these all look like huge, huge positive numbers. I don't even know how I'm going to do this. 1, 2, 3, 4, 5. And we have to, on the y-axis, get the whole way up to 2,500. So I might count by 500s. So 5, 1,000, 1,500, 2,000, 2,500. So this is 500. This is 1,000. This is 1,500. This is 2,000. And then this is 2,500. Okay, so 2,500. huge. 2, 500. 3, 100. 4, 20. And then they get insanely tiny based on my scale over here. So, because 5 is at like 4, it's way down there. So again, what do you notice? Well, it looks like exponential, and this time it looks like exponential decay. Letter B, 80, negative 40, 20, negative 10. Okay, so let's set up our table. One, 2, 3, 4, 5, 6, 7. Then let's go find our pattern. 80 to negative 40. Well, 80 to 40 is kind of like 1/2. Okay, I cut it in half. 40 to 20, also kind of like 1/2. 20 to 10, also like 1/2. But do you notice it's going positive, negative, positive, negative? How do you get it to cut in half and switch the sign? Well, we're going to multiply by a negative 1/2. We're going to multiply by a negative 1/2. A positive times a negative is a negative. A negative times a negative is a positive. A positive times a negative is a negative. And then we're going to keep going. So if we times by 1/2, that's 5. And a negative times a negative, is a positive. Then we're going to cut that in half again. Keep in mind, positive, negative, positive, negative, positive, negative, which is going to give us 5 halves. And then times by negative 1/2 is going to give us a positive 5 fourths. First part of the question, here's the next 3 terms in the pattern. Then we're going to graph it. And this time, I've got positives and negatives. So I think I'm going to do a graph kind of like this. 1, 2, 3, 4, 5, 6, 7. Then I know this guy gets up to 80, so I might go 10. 10, 20, 30, 40, 50, 60, 70, 80. 10, 20, 30, 40, 50, 60, 70, 80. And I'm only labeling every other one just for the sake of time. Okay, so 180, 180. 2, negative 40. 3, 20. 4, negative 10. 5, 5. 6, negative 5 halves. 7, 5 fourths. What do you notice? Does it still look exponential? And it does. It's just half of it's kind of like on the top, and half of it's kind of on the bottom. This one is kind of exponential decay. This one is exponential decay. It's been flipped over the x-axis. Kind of a funny looking guy, but that is what he looks like. Letter D. Okay, once again, set up your table. One, 2, 3, 4, 5, 6, 7. Okay, so now we've got, we have to find the next 3. Sorry, I lost my train of thought. Negative 2 to 4. Well, 4 to negative 8. Once again, do you notice positive, negative, or negative, positive, negative, positive? So this time it looks like our common ratio is going to be a negative again, and 2 to 4, we're going to multiply by negative 2. So a negative times a negative is a positive, and then times by negative 2, times by negative 2, so we're going to keep going. So 16 times negative 2 is negative 32, then times by negative 2 is 64, then times by negative 2 is negative 128. Then we have to graph this. So once again, because we're kind of flip-flopping, I'm going to do a graph with my x-axis in the middle. 1, 2, 3, 4, 5, 6, 7. This time it looks like we've got to get out to like 128. So maybe we count by 20s. 20, 40, 60, 80, 100. 20, 40. So 20, 40, 60, 80, 100, and then 120, and then 140. And then same thing, 20, 40, 60, 80, 100. So negative 20, negative 40, negative 60, negative 80. Oops, sorry. This one's negative 80, this one's negative 100, negative 120, negative 140. There we go. Okay, so over 1, down 2, which is tiny. Tiny, 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 tiny. Over 2, up 4, still pretty tiny. Over 3, down negative 8. Over 4, up 16, so we're almost at 20. And then over 5, down 32, which is not quite the 40 mark. Over 6, up 64. And then over 7, down 128, which is going to bring us to that second to last. So do you see it? On the top, you've kind of got that exponential growth going, but half of the graph is then below, which is the exponential growth that's been reflected over the x-axis.